All right, as we begin section or module 3, we're going to look at rational functions. So what is a rational function? So a rational function is any function of the form, we're going to call it f of x equals p of x over q of x, where q of x cannot be 0, where p of x and q of x are just polynomial functions. So we're just taking two polynomials and we're dividing them. So what are some examples of rational functions? One example might be f of x equals 3 over x minus 1, because you have a constant function 3 over x minus 1. Or g of x equal x squared minus 4 over x cubed minus 6. All these are examples of rational functions. Now, unlike polynomial functions, where they have kind of this nice, neat family of functional curves that kind of look the same, rational functions can take all different shapes and sizes. So instead of trying to see what they all look like, all parabolas, all cubics, things like that, what we try to do is we try to figure out parts of them and try to use that to make an idea of what the graph looks like. Now, earlier we said in the definition that it was a quotient of two polynomial functions to make a rational function, but q of x couldn't be 0. And that's simply because you can't have the bottom fraction be 0 because you can't divide by 0. And that really leads us into our discussion of what the domain of these functions are. And domain is a really important thing for these functions. So the domain, just like any reciprocal function that we talked about earlier in the course, domain is just all real numbers except for those x that will make the denominator 0. So if it makes the denominator 0, then we have to exclude it. So here are some examples. And so this says find the domain of each of the following rational functions. So the big idea is we want to see what makes the denominator 0, and we have to exclude those. So the easiest way to do this, and what we'll do a lot in this section, is we do a lot of factoring. So what I can do is I can factor x squared minus 25 as x minus 5x plus 5. And we have a whole myriad of techniques that we learned from the previous module on how to find zeros and how to find those of polynomial functions. But if you look at these, for these two factors, x minus 5x plus 5, what makes that 0 is 5 and negative 5. So that's simply going to be our domain is going to be all real numbers, x not equal to 5 or negative 5. So interval notation, negative infinity to negative 5, union negative 5 to 5, union 5 to infinity. So those will be very interesting, and whatever makes the domain excluded, those are actually pretty interesting too. So let's look at this one, same idea. So we'll factor this one. So the top, and again, the top doesn't really matter for the domain, but always good to include it. So this one, I see I can factor out an x, left with x squared minus 5x plus 4. And then if I factor the denominator here, I have x minus 4, x minus 1. Because remember, when you're factoring, you're looking for two numbers that multiply to 4 and add to negative 5. So in this case, we actually have three factors. This one is pretty obvious, this one's pretty obvious, but don't forget about this little term of x. That is going to be very important when we talk about our domain. Because the numbers we're going to exclude are going to be 0, it's going to be 1, and it's going to be 4. And in interval notation, negative infinity to 0, union 0 to 1, union 1 to 4, and 4 to infinity. So basically, any number is fine to plug into that function, except for those three numbers. Now you notice that this numerator was x plus 2, and I could put in negative 2 there to make that 0, but that's the numerator, so that does not matter for the domain. Only the denominator is really what matters. The other thing we like to do in rational functions, we like to put it in lowest terms. Now we've all heard of lowest terms fractions, because if you were in grade school and you had the fraction 4/8, then what we know is 4/8 is 1/2, because they both divide by 4. Now we're going to do it a little different way when we talk about polynomial functions, but really a rational function is lowest terms. So for a polynomial function, something that's going to be in lowest terms is just going to be a rational function with all common factors canceled out. So if we think about this fraction, 4/8, it's in lowest terms because there's no factor that can cancel it. You could also think of 4/8 as 2 times 2. And you can think of 8 as 2 times 2 times 2. And then you could just cancel these common factors out, and that's how you could also get 1/2. A little different way to think of reducing fractions, but that's the way we'll do it in polynomial functions. So if I had something like x minus 1 here and x minus 1 x plus 2, then I'd want to cancel that out and be just left with 1 over x plus 2. So lowest terms is always a better way to go because it'll make our rational function easier. Now when you do cancel something out, that will mean something important down the line. So let's look at a couple of examples where we're going to put things in lowest terms. So we have x squared minus 2x minus 8 over 2x squared plus 2x minus 40. Again, good idea to go ahead and factor it since it's not. So that's x minus 4x plus 2, two numbers that multiply to negative 8, add to negative 2. And this is always a good time to practice your factoring. If I look at the bottom here, I can take a 2 out and be left with x squared plus x minus 20. And then I could factor the remaining trinomial in the denominator. So x minus 4x plus 2 over 2, x plus 5, x minus 4. So you can see that I can cancel this out. So my rational function in lowest terms is going to be x plus 2 on the top, a 2, and an x plus 5 on the bottom. Now the second part of this question says, what is the domain? And this is pretty important. So I'm going to have all real numbers. I'm going to exclude negative 5 because it makes the denominator 0. But I also have to exclude 4. So even if you do cancel that factor out, you still have to exclude it from your domain. And the reason that's true is if you have 4 in your function, you're basically canceling out 0 over 0. And 0 over 0 does not cancel out. It is not 1. It's actually an undefined value. So even if you cancel out, make sure you exclude that from your domain. Now this last one is even in better shape because it's already factored out. So all I have to do is just really look for the common factors that cancel out. And I think it's just x plus 2. So this one in lowest terms is just x plus 9 over x minus 3, x plus 4, x minus 5, and x minus 7. So a relatively straightforward one there. Now domain-wise, we're going to have lots of exceptions. We're going to have all real numbers except 3, negative 4, 5, and 7. But again, I want to make sure I include that negative 2. Even though I canceled it out, that's what makes that factor 0, so I want to make sure I exclude that. And again, all these are really important things. All these numbers are going to mean something very important from the graph. And then the one that cancels out is going to mean something totally different for the graph of a rational function. So hopefully this is a pretty straightforward introduction to rational functions. Please let me know if you have any questions.